Feature engineering, a term that sounds complex but is at the heart of machine learning magic. It's about molding raw data into insightful features that boost our model's performance. So let us understand this concept step by step. First, we've got to understand that feature engineering isn't a one-size-fits-all process. It's adaptable, fluid, and influenced by the unique attributes of each project. It's a blend of domain knowledge, data exploration, and experimentation, all working together to craft features that resonate with the task at hand. So, in this project, we will first start by splitting the dataset into features and targets. Think of features as the data that guides our predictions, while the target variable is what we aim to predict or classify. So in this particular project, our features are nothing but the measurements of the sepal and petals of iris flowers, and our target is the species that they belong to. So here in this line of code, we are dropping the ID and species column from the iris data frame by making use of the drop function, and here axis equal to 1 represents to delete from the column and not from the row. We are dropping the species column because we know that this is the target in our project, and we are also dropping the ID column because all the values in that particular column are unique. So it is not necessarily going to impart any new information or a pattern to the classification model, and on the contrary, it may confuse our model. So it is better to remove such kind of uninformative columns from the data set before training. So all the rest of the column in the data set are going to be considered as features, and we are saving all these features into a variable called x. And here we are simply saving the target into a variable called y. You can see here that from the iris data frame, we have accessed the species column and we are assigning it to a variable called y here. So here x is our feature and y is our target. Now that we have splitted our data into features and targets, scaling is what comes next. Now numerical variables often have different ranges, which can lead to biased models. So scaling brings them to a common playing field, ensuring fair comparisons during model training. As you could see here, you can see that the values of these features are varying. You can see that the sepal length ranges from 4 to 7 and sepal width ranges from 2 to 4. The same is with the other columns as well. So by scaling, we bring them to a common playing field, ensuring fair comparisons during model training and to avoid biases. Here we are going to make use of the standard scalar class that we imported in the first step of our machine learning project, that was importing necessary libraries. Here in this line of code, what we are doing is we are creating an object of standard scalar class which is being called as scale in here. And by making use of that object, we are calling the fit transform function, and to that function we are passing in the features. So all the features that are passed into the fit transform functions, that is the measurement of the iris flowers, are being scaled and assigned to the x scaled variable. So this variable here represents the scaled features. Also please note that the outcome of the fit transform function that is being stored in the x scaled variable is an array. And in the next line of code, we are doing nothing but converting that array into a pandas data frame. As you can see here, we are making use of the data frame function from the pandas library, and to the columns we are passing in the name of the columns of the features, and the data is nothing but the scaled features. So these are the features. Now you can see that they have been transformed, that is they have been scaled, and now they all have a uniform range. So that is how we could deal with the numerical variables in our features. And please note that in this project our features are only numerical, so scaling alone would suffice. So now that we have learned to scale our numerical features, we move on to the next step, that is encoding the target variable, that is the species of the iris flower. Encoding categorical variables is a fundamental step in feature engineering. Categorical variables need to be transformed into numerical representations for machine learning algorithms to process them effectively. This process assigns unique numerical codes or creates binary dummy variables to represent the categories. Encoding categorical variables is important because it allows algorithms to capture the relationship between categories and the target variable. So here we are making use of the map function that is offered by the pandas library, and to this function we are passing in a dictionary that is storing the transformation of the iris flower species. So to this dictionary we have passed that the iris setosa species should be represented by 0 and iris versicolor species should be represented by 1 and iris virginica should be represented by 2. And on running this cell of code, you can see that now the target variable is having integer type values ranging from 0 to 2. That is representing the species in the iris flowers, that is iris setosa, iris versicolor and iris virginica respectively. So this form of coding is actually called label encoding. Okay, so to these species we have just provided the labels 0, 1 and 2, and now they are converted from categorical into a numerical format to be a suitable input to the machine learning model that we are going to use. Please note that in the coming section of the project we will be implementing the decision tree algorithm, and for that algorithm this step was not necessary. But since encoding is a task that is very crucial to machine learning projects, we chose to introduce it here as well, and it won't be affecting the performance of the model in this project. And now we have learned to encode the categorical variables in a dataset as well by implementing label encoding by making use of the map function. So now we have learned to encode a target variable as well. Our next step is to split the data into train and test set. So let us come to the code. Here in the commented line you can see the line that we used to import the train test split function in the importing necessary libraries section of the course. And here we are making use of this train test split function. So this function works by randomly shuffling the data and dividing it into training and testing sets. To this function we are passing in the scaled features and the encoded target variable, and we are setting the test size parameter to be 0.2. This is to suggest to the train test split function that the testing size of the data should be 20% of the entire data and the rest of the data should be assigned to the training set. After that, here we are setting the random state in order to ensure the reproducibility of the shuffles that are being implemented by the train test split function before dividing the data. So once you run the code, you are assigning the values to these variables in here, and please note the order in which these values are written. Okay, because that is also very important. Firstly, we are assigning the train and test for the features, and then we are assigning the train and test for the targets. And one way to remember this order is by looking here at the parameters of the train test split function. You can see that x comes before y. So here also the train and test of x would come before the train and test of y's. So this is one important thing. People usually get confused while using the train test split, like which set should come first, but please make sure that x's are before the y's. After that, here we are doing nothing but just printing the shape of all these sets you can see that in X train and Y train, the number of data points are the same, that is 120, and the similar case, and it is the same for the test set as well. And you can also calculate the percentages, that is here 30 represents the 20% of 150 and the remaining 80% is 120. So we have now splitted our data set into training and testing set. Now all that remains is to train our machine learning model and to evaluate its performance. That we'll be doing in the next section.